Hello everyone and welcome back to the channel. Imagine your amazing website or application suddenly becomes hugely popular. Great, right? Well, not if all that traffic is hitting a single server, making it slow down, crash, or just not respond. How do massive online services handle millions of users without their servers melting down? The answer is often an unsung hero of system design, which is the load balancer. Today, we are diving into what a load balancer is, why it's absolutely essential for modern application, and how it intelligently keeps your services running smoothly. Okay, so at its core, a load balancer acts like a smart traffic cop standing in front of your servers. Its primary job is to efficiently distribute incoming network traffic across a group of backend servers, often called server farm or backend pool. Instead of requests directly hitting one server, they first hit the load balancer. The load balancer then decides which healthy server in the pool is best suited to handle that specific request and forward it there. This is a simple concept, is fundamental to building a scalable and reliable system. Okay, let's just take an example to understand what is load balancer truly are. Let's say that we have a client one, okay, and the client sends request to our server, okay, and everything goes well. Let's say that our application gets too popular, so we have client 2 and client 3, and let's say our server can handle only one client, and we cannot add more resources to our server because our server reaches its physical limits. So what should we do? We should horizontally scale our application. So we add server 2 and we add server 3. Okay, now we have servers that can handle these clients, but we need something in the middle to direct the client to a healthy server, and also to make sure that all the servers are balanced. Like we want to make sure that we have no server that is underutilized or a server that is a bottleneck. We want to make sure that every server has the right amount of requests. So we will introduce a load balancer to our system. The load balancer will distribute all the incoming traffic that coming from the clients across these servers. Okay, making sure that each client, when the client try to hit the load balancer again, the load balancer will always redirect it to the same server. That means the client doesn't lose its cache. That means the server that is not overwhelmed with a lot of different requests, because the load balancer is balancing the load. It makes sure that we have no server is overwhelming with requests and we have no server is underutilized. So this is what is a load balancer on a high level, and in the future videos we will talk about that in more detail. Okay, why do we need, or why load balancer is essential? Load balancer isn't just nice to have. They are critical for several reasons. One is scalability. They enable horizontal scaling. Instead of updating a single server, which is vertically scaling, to handle more traffic, you can simply add more identical smaller servers to your backend pool. The load balancer ensures that traffic is distributed among them, allowing your application to handle virtually unlimited user loads. But two, high availability and fault tolerance. Load balancers continuously monitor the health of your backend servers. If a server goes down, becomes unresponsive, or shows sign of failure, the load balancer automatically stops sending traffic to it and redirects requests to the remain healthy servers. This ensures your application stays online even if individual server fails, providing high availability. Number three, we have improved performance. By distributing traffic evenly, load balancers prevent any single server from becoming overloaded. This results in faster response times for users, lower latency, and more consistent user experience across the board. Lastly, flexibility and maintenance. They allow you to perform server maintenance, like software updates or hardware upgrades, on individual backend servers without any downtime for your application. You simply take a server out of the load balancer's rotation, perform a maintenance, and then put it back in. Okay. So we need to understand how does it work. So let's go to our example. Let's say that we have a client. We have our load balancer. We have our servers S1 and S2. Okay. So first, the request flow. Like when a client make a request, first it hits the load balancer's IP address. This is the first thing. Okay. The second thing, the load balancer continuously sends small health checks, props, like pings or maybe HTTP requests, to each backend server. If a server doesn't respond or responds with an error, it marks it as unhealthy and temporarily removed it from the pool. So the load balancer will just try to check here these two servers and send to them health checks to make sure that if they are healthy or not. If they are healthy, let's say that both of them are healthy. Once a server is deemed healthy, the load balancer applies its chosen algorithm to distribute the load. There is different types of algorithms. There is round robin, which is simply sends requests to the servers in a cyclic order. Like let's say it's server 1, after that I send server 2. So if another request comes, it will be server 1, that's server 2. It's a cyclic order. There is another one called least connection, which sends new requests to the server with the fewest active connections, aiming to balance current workload. We have least response times, like sends requests to the server with the fastest response time and fewest active connections. We have IP hash, directs a client's request to the server based on their IP address, useful for session thickness, though this can lead to uneven distribution. And number 4, we have a traffic forwarding. The load balancer forwards requests to the chosen backend server. The response from the server then typically flows back through the load balancer to the client back. And yeah, that's it. Okay, so we'll talk about types of load balancers. We have hardware load balancers. It's a physical appliance offering high performance and dedicated processing, but are expensive and less flexible. We have a software load balancer. These are applications that run on standard servers. They are more flexible, scalable, and cost-effective, dominating modern cloud deployment. We have layer 4 load balancers. This operates at the transport layer. They make decisions based on IP address and port. They are fast and efficient, simply forwarding packets. We have layer 7 load balancers. Operate at the application level, HTTP and HTTPS. They can inspect the actual content of the request, like URL path, headers, cookies, etc., to make more intelligent routing decisions. They are more feature rich. They have SSL termination, content-based routing, but also consume more resources. Okay, in conclusion, load balancers are the indispensable backbone of virtually all high-traffic modern applications. They ensure your services are scalable, highly available, and performant by intelligently directing traffic and managing server health. Whether you are building a small web app or a global enterprise system, understanding and utilizing load balancers is a key, delivering a reliable user experience. They truly are the traffic cops that keep the digital world moving smooth. So yeah, that's it for this video, and see you in the future.